Hey guys, welcome to another math video. For this one I'll be showing you how to derive the quadratic formula. Alright, so that's pretty much what we'll be doing. Okay, so let's get to it. So this is the end result, the quadratic formula here. You've probably seen this somewhere. So I'll be showing you how we get to this. So what we're going to do is we're going to start with the standard form of a quadratic equation, which you've probably seen as this. Okay, so first thing we're going to do is we're going to move the constant away from all the variables. So in this equation, the constant will be your c. So to move it from the opposite side of the equal sign, we're going to add the opposite. So this is all going to be algebra. So we're going to subtract c from both sides of the equation and get something that looks like this. Okay, now a is your coefficient of x squared. Now this is assuming a is larger than 1 or between 0 and 1. That means a is not 0, a is not 1. But it's either a fraction or it's a number. Well, it's a fraction between 0 and 1 or some kind of number that's larger than 1. So the next thing we need to do is get rid of it. So to get rid of it, we're going to divide each term by a. Get something that looks like this. Alright? Now the next thing we need to do is, well, we don't need to do it, but it's going to make our lives that much easier. What we're going to do next is we're going to complete the square. Now, in this case, your b term is going to be the b over a you see attached to the x variable. So in order to complete the square, we're going to take the b over a, we're going to divide it by 2 and then square it. And we're going to add that to both sides of the equation. So after you divide b over a by 2, you should get b over 2a, and if you square it, we get b squared over 4a squared, which is what we'll add to both sides. Okay, so now on the left side of the equation here, we have what's called a perfect square trinomial. So we can rewrite that perfect square trinomial to look like that. And on the right side, what I'll do is I'll combine the two fractions by creating a fraction that's equivalent for the c over a, so that we can combine it with the b squared over 4a squared. So I'll need to multiply 4a to the top and bottom of the c over a fraction in order to get a common denominator to combine that into one large fraction. Okay, so on the other side here we got a perfect square binomial because it's got two terms. Okay, if you're not sure how to do that, check out my other video on perfect square trinomials and or factoring. Alright, okay, so next step, we want to get rid of that square. So I'm going to square root both sides. Okay, pretty simple here. Okay, so now when you square root a perfect square, they actually cancel each other out. It's like how addition and subtraction are opposites, or multiplication and division are opposites. So squares and square roots are opposites of each other. They'll cancel each other out. Okay, and on the right side of the equation, nothing in there is going to be able to simplify except for what's in the denominator. And it's important to note that if you're working in an equation and you have the square root, if you're taking the square root of something, you're going to have two answers. One's going to be positive, one's going to be negative. So this will simplify to look like this. Okay, so on the left side of the equal sign, basically we're just canceling out the square and the square root. On the right side of the equal sign, the numerator, there's nothing in there we can factor out or reduce because we gotta take the b squared minus 4ac as a whole. Can't break it apart. because the whole thing is under the square root. It's not the square root of b squared minus the square root of 4ac. It's the square root of b squared minus 4ac together, which means in order for you to reduce it, it has to be reducible from the whole thing. But the denominator, 4a squared, we can reduce that because they're together, which means we can separate them. Well, they're together by multiplication. So if you check out my other video about reducing square roots, it'll make a lot more sense. Alright, now the last step here is to get the x variable by itself on one side of the equal sign. So we're going to take the b over 2a and we're going to move it to the opposite side of the equal sign, just like we did with the c earlier. So we're going to subtract it from both sides of the equal sign, get something that looks like this. And since we have a common denominator for these two fractions on the right side of the equal sign, we can combine them into one giant fraction, which looks like that. And we have successfully derived the quadratic formula. Okay, so to sum everything up, that's what we did. What we did was we started with the standard form of a quadratic equation, and basically we're just solving for x. So a lot of people get tripped up on this because there's no numbers to start out with, so they get confused. But if you treat the letters as numbers, the non-x letters as numbers, I think it'll make a lot more sense. Anyway, thanks for tuning in, and I hope you learned something. Check out my other videos, and see you next time.